Welcome to this lesson on chemical equations. A chemical equation is a powerful tool that chemists use to represent what happens during a chemical reaction. Throughout this video, you'll learn how to write and interpret these equations, understand the symbols used, and discover why balancing equations is essential in chemistry. A chemical equation is a symbolic representation of a chemical reaction using chemical formulas and symbols. Instead of writing long sentences to describe a reaction, scientists use a compact, standardized format. This makes it easier to communicate chemical processes clearly and efficiently. Think of it as a shorthand language that tells us exactly what substances are involved and what they produce. Every chemical equation has two main components. First, we have reactants, which are the starting substances that undergo change during the reaction. Second, we have products, which are the new substances formed after the reaction takes place. Understanding these two components is fundamental because they tell us what we start with and what we end up with in any chemical process. Chemical equations follow a specific format. Reactants are written on the left side, and products are written on the right side. Between them, we place an arrow that points from reactants to products. For example, hydrogen gas plus oxygen gas yields water. The arrow essentially means reacts to produce or yields. This simple structure makes it easy to understand the direction of the reaction at a glance. Chemical equations use several important symbols. The arrow symbol means yields or produces. The plus sign means plus or combines with and is used to separate multiple reactants or products. We also use state symbols in parentheses. The letter S in parentheses indicates a solid state, while the letter L in parentheses indicates a liquid state. These symbols help us understand the physical form of each substance in the reaction. There are additional symbols you'll encounter frequently. The letter G in parentheses indicates a gas state. The letters Q in parentheses stand for aqueous, meaning the substance is dissolved in water. The Greek letter delta above the arrow indicates that heat is applied to make the reaction occur. Finally, a double-headed arrow with half arrows pointing in opposite directions represents a reversible reaction, where the reaction can proceed in both forward and backward directions. Let's look at a real example. When methane gas reacts with oxygen gas, it produces carbon dioxide gas and water in liquid form. Notice how we include the coefficients and state symbols. The number 2 before oxygen tells us we need 2 molecules of oxygen. The number 2 before water tells us we produce 2 molecules of water. This complete equation gives us a clear picture of the combustion reaction that occurs when natural gas burns. One of the most important principles in chemistry is the law of conservation of mass. This law states that matter cannot be created or destroyed in a chemical reaction. Therefore, the number of atoms of each element must be equal on both sides of the equation. This is why we need to balance chemical equations. A balanced equation ensures that we have the same number of each type of atom before and after the reaction. Here's a comparison between an unbalanced and balanced equation. The unbalanced equation shows hydrogen plus oxygen yielding water, but the number of atoms on each side is not equal. In the balanced version, we place a coefficient of 2 before hydrogen and 2 before water. Now we have 4 hydrogen atoms and 2 oxygen atoms on both sides. This satisfies the law of conservation of mass and accurately represents the chemical reaction. Chemical equations are symbolic tools that help us represent and understand chemical reactions accurately. They provide a universal language for describing what happens when substances react. By learning to write and interpret chemical equations, you gain the ability to predict products, calculate quantities, and understand the fundamental processes that govern the chemical world around you. With practice, reading chemical equations will become second nature.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.